Okay, we're back. So let's head through 3 examples looking at this, and starting with this first one. OC is a radius of the circle with center O, and just maybe a quick note on that because I don't want to kind of belabor these too much, but O is told that that's the center. Never assume that something's the center unless you're told it or you've proven it. And it cuts the chord AB at M. Okay, cool. So, with anything, any sort of diagram stuff, but particularly when it comes to these diagrams, the first piece of the puzzle is definitely that you're reading through this, and so I'll do it maybe less as we go along, but just to hammer these points home early. And that is when you're reading through these, you're matching up what's here and what's in the diagram. So maybe you're told stuff here that's not in the diagram, and you're just marrying the two. So, as I said, I'll take you through this first one a bit more, and then maybe as we go along more, it's a bit of okay, just see those, take a pause when you need to. But so let's do a bit more in these first. Okay, rambles over. Stop your rambles, you, right? Okay, so OC equals 17. So that was a bit of information we weren't told. I guess it might be hard to show in the diagram, but OC, that is 17. AB equals 30. So yeah, I guess this is why these things weren't. That thing there is 30, and OC is perpendicular to AB. So that is 90 degrees. Okay, that's way too confusing, so let's just hold off writing some of those things, but keep it as that's the center. Find the length of MC. So maybe at this stage, think about the theorems that we've just looked at, and just think through, what are your ideas or strategies to get into this? It doesn't have to be in detail. And maybe as you thinking through that, sometimes with circle geometry, you're going to have more of an overall strategy and then just go, okay, well, I'm just going to kind of get myself through. Or maybe you've got a strategy that gets you a certain way through, and then at that stage, more is going to be revealed to you. So you might go, oh, well, I know that something, but I don't want to say what that something is the first thing that seems obvious to me. Or you might have an idea of how you're going to finish this whole question. Great stuff. Or somewhere in between. So go for it. Kind of quick ideas of some strategy here. Okay, so you've put down some ideas, and, you might hear me often say this because it is something of there might be different ways of looking at this, and each of these might be valid. There are going to be a few different ways to solve this. You might construct a kite in this whole thing and use properties of a kite somewhere, and that would be great. Now, I'm not going to use a kite in this particular example, but hey, maybe that's something you did and that would be great. So the things that stick out to me, if this whole length here is 30, I kind of already know that must equal that, and each of these must be 15, right? That seems like something obvious. Now, again, I'm talking around this a lot more in these first videos because we're going to just take these for given later, or these strategies of, how much do you scribble on the diagram and then start writing everything down? Or do you want to go, well, those two are equal. Now, wait a second. I've written that, but I haven't shown my reasoning. So I need to give a reason for that. So I need to say AM equals BM equals 15. They're each 15. I'm not going to be bothered with units until the end. And I've made a statement and I need to write a reason. So you may, pros and cons for me are, you don't write it down straight away. A con is that you forget to write it down, or you don't write down with your great reasoning. If you do write it down like now, you might lose some of your momentum. So you've got this idea and then, you get bogged down by writing it down. So really going to be up to you how you manage those two and hold that in your head. No golden strategy here for which is better. Write down everything as you go, or kind of figure it out and then write it down. One thing to make sure is that when you're writing this down, make sure that we can read it in order. So we're going to make a statement here that relies on this statement here. You clearly must have made this statement first before this one. You can't go the other way around. So just think of that order is going to be important. So that's maybe a disadvantage of going that. But the momentum. So already you see my momentum's lost. How's your momentum going? Okay, so we used this idea, right? This very first one. Line drawn from center, perpendicular to chord. So I sometimes wish that you just had a whole lot of stamps And you could just kind of pick from that and go, okay, I'm just going to stick that reason in over there. Because it's a pain to keep writing them all down. But anyway, so I'm going to cheat and do that. But you need to write line from center to perpendicular to chord, because you were given it's perpendicular. Okay, now this whole thing here is 17, and we're trying to find the length of MC. So maybe what we do is we write that this length is x, because that's what we're trying to find. And if the whole thing here is 17, maybe this is 17 minus x. That might be a strategy that we've got. Maybe it seemed useful previously that we drew in some radii, so maybe some radii would be useful. We know that radii are all the same length, so that's handy. So wait a second, we've just drawn a radius, but this is also a radius. So therefore those two are the same length, which means this one must be 17. So now what we've constructed, and I would definitely recommend you do not redraw triangles like I'm about to do, but I just want to kind of pick out the bit that I've drawn. I've just drawn a nice triangle where this is 17 minus x, this is 15, and this is 17, and it's a right angle triangle. So maybe you wrote this earlier because you already knew how to do it, in which case you could be like, yeah, I said this earlier. Or does it become a bit more apparent whose theorem, right angle triangles, we're going to use, and therefore how we're going to get home? Okay, so hopefully that's coming a bit clear. Now we're going to use Pythagoras' theorem and then go that squared plus that squared equals that squared. We'll have an equation and we can solve it. But we just need to maybe capture some of our thinking. So we can say maybe let MC equal x. Therefore, OM equals 17 minus x. It's just algebra, so we don't need a reason. Construct, because we're drawing it, so construct radius OB, and OB equals 17. Now we've used the word radius here, so we've given our reasoning. So what we can say there is, as we're writing it, we've got it in the diagram. So we can say, okay, well, 17 minus x squared plus 15 squared equals 17 squared. We made a statement. Our reason is glorious Pythagoras, I think. And then you can solve from there and get your value of x. Now, it's nice that we made that x and not this x, because we could get directly to our answer. So I think I need a calculator for this one. So solve it. And, whoa, that calculator just appeared. And so, yeah, 17 squared gives us something other. But I'm being silly, because if I just write 17 squared, it's going to kind of cancel nicely with that one, right? So minus 34x plus x squared plus 15 squared equals 17 squared. Goodbye, goodbye. So x squared minus 34x plus 225, is it, equals 0. Okay, well, that's not too bad. How are we going to factorize that there? We got a good idea there. I think, isn't it just 25 and 9 for this? Let's just, where's our calculator here? We're saying 25 times 9. Yeah, that makes 225. So if we factorize that, x equals 0. So 25 and 9, I think it's minus 25 minus 9. So therefore we've got two solutions, x equals 25 or x equals 9. Now, just wait a second. One of these definitely doesn't make sense. Which solution doesn't make sense, and why not? Well, if x is 25, then that line that we've drawn from OMC, well, that's 25, and that's 17 minus 25. So that's, well, I'm just going to stop there. It's a negative number. That doesn't make any sense. So therefore, it was interesting to see, but we're going to cross it out, and perhaps we're just going to circle that one to say 9 makes a bit more sense, because then, that whole thing, that would be 9, and that would be 17 minus 9, which I think gives us 8. So 8 and 9, that makes more sense rather than one length being a negative length. Okay, so that's that one. Let's kind of get, as I said, I want to start building up the momentum a little bit more. So, hello, calculator, come and gone. A, B, and C, D are two chords of the circle with center O. OE is perpendicular, so all of this information, I'm just going to pause. Just be happy that whatever's in here is in the diagram, and you can match the two and draw it down if you don't have a printed version. Okay, so out of all of that, the things that they didn't tell us here is that OE equals 4, so O equals 4, OF equals 3, and AB equals 8, which they're basically told that is 4 and that is 4. Find the length of CD. So we're trying to find this whole length over here, right? So let's see, that's what we're trying to find. Okay, so maybe, again, let's just see, jot down what your strategies are, and I'm going to run through this one a little bit quicker, still with as much detail, but a little bit quicker, and rather just, I'm going to go through all the momentum of doing it here, and less on the nitty-gritty of jotting it down. Still do that. Okay, enough of that. Jot down ideas. Okay, so again, I'm going to read through ideas, and I always read through ideas that you give and go, yeah, that would have been an interesting way to do it, and I learned through that as well. And then think, well, hopefully you follow through with that idea and don't just think, oh, we'll do it my way now. So here we go. I think my idea is that it's kind of nice to have some radii, because radii are always the same length. So if we've got 3 and we've got 4, I mean, this is just dying out to be a right angle triangle with this being 5. But we can't say that that's 5. We can't use Pythagoras unless we know this is 90 degrees. Of course, we do know it's 90 degrees because those two are equal. So if we label these, say, like F1 and 2, then we could say F1 equals 90 degrees, and we're going to need a reason for that. So we go up and we go, wait, if we draw a line from the center to the midpoint of a chord, if we are given that, then it's going to be 90 degrees. So we go write that long-winded reason over here, and whatever. It's going in there. It doesn't just fit. Okay, no, it's not fitting. So yeah, we go. So there it is. We got that 90 degrees. Therefore, 3, 4. Hey, that worked out nicely. That OB equals 5. In other words, the radius equals 5. How do we know that? We used our dear old friend Pythagoras. Didn't even need the calculator for that. 3, 4, 5. So therefore, if we draw another radius, let's say we draw it over here, then we know that that radius must also be 5. So, I could use the word construct OD. I'm just being quick and working the two together. And so OD equals 5. How do we know that? It's a radius. And therefore, 4, 5, it looks like this should be 3. Oh, it's already been told that it's a right angle, so we can go straight there. ED equals 3. Well, if that's 3, that's 3. Hang on a second. Why? Well, if ED is 3, CE is 3, and we need to give a reason. Even this ED, we needed to say Pythagoras. Pythagoras got a bit strange there, didn't he? Pythagoras, this, Pythagoras. And for this one here, if we're given that it's perpendicular, then we know that it's that. So in other words, the line from the center perpendicular to the chord. And I'm going to go and copy paste here and go line drawn from center perpendicular to chord. That reason goes in there. That goes in there. That one over there. And okay, well then we've got it. So therefore CD equals 6. Okay, so hopefully that gave the momentum of what we're trying to do as we went along, and we're jotting it down. Now, yes, next example, ready to go. I think you're ready. I don't need any crickets for that one. I'm going to head into the last one and go, the diagram shows a semicircle with center O and a whole lot of other information. Let's head into this. EF equals down. So maybe some things that aren't given you are radii. Like it seems like radii seem to come up a lot, right? Radii. Try and say that quickly. It's not too bad, I guess. So if we've got this radius, this is a radius, this is a radius. Any other lines we draw are going to be radii, so we can kind of draw lots of these radii. This bit over here is a radius, so that could be R, so that whole length. Okay, so there's some ideas for you to play with, and EF. So what I'm going to do is I'm always aware of the time, but trying to get that balance, right? Of going through it thoroughly, but maybe leaving class time open for you to ask for a little more detail if you want it, or if you're just getting it, then going through as well. So got a semicircle, center O. O. EF equals 9. 9. AB equals 42. 42. And OEF is perpendicular, so this is at 90 degrees. So already if that whole thing is 42, we're going to go 21, 21, right? And we're going to capture that with our reasoning. So I'm going to not do as much of the writing down here, but rather just work through more on the diagram, and you're going to have to write this down nice and neatly. So we got 9, 21. Calculate the length of CD. Okay, in other words, calculate the diameter. In other words, calculate what the radius is and times it by 2. So as I said, kind of feels like we want to construct some sort of radius here. So we've got a right angle triangle. If that's 9, we don't know what the radius is, but if our radius, say now this is R, this is R, this thing here is R minus 9 because the whole thing's R, so that's R minus 9. Well, it looks almost identical to the question we did earlier. Wow, that's a big splodge. So we've got that wonky triangle over there where we've got 3 side lengths and it's right angled. Okay, so I'll leave it to you to work out or to write down all that nice reasoning and for you to get an example. And when you do, you can be like, yay, I got such a lovely example. And you can really give yourself a pat on the back and be like, yeah, thank you, thank you, thank you, thank you, thank you, thank you.
And remember to make it bats.